Hi, everyone. Thanks for coming to the session. My name is Anees Shaikh. I work at Google in the network operations team. I'm in the network architecture group within the operations side. I was actually at an Open Daylight mini summit about a year ago. It was August of last year, talking about the management plane. And really the theme of that discussion was around how SDN has sort of passed by the management plane, and we focus so much on control and data. We have some fantastic technologies in terms of open control stacks like Open Daylight, open data planes like OVS and other virtual switches, and a bunch of other open networking technologies. But as far as the management plane is concerned, we still have a bunch of gaps that I will talk about today. And so the motivation of that talk last year was basically saying, hey, we have been focused a lot on SDN from a control and data plane perspective, but we also need to put a lot more emphasis on management plane, because for network operators like Google and many others, operations are really where we see a lot of the pain points in deploying new technologies and operating them. And I ended the talk last year with some discussion of some ideas we had at that point about how we could do this work in terms of generating an open and equivalent in the management plane in a collaborative fashion. So just as Open Daylight has leveraged collaboration and community to a large extent to build a stack and a whole set of features and is slowly improving in its maturity, we didn't quite follow exactly the same model, but we also are trying to leverage collaboration. And so this is sort of an update of how far we've come in the first year. So that was August last year. We're just about in August of this year. So this is basically an update on where we are. So OpenConfig is sort of the brainchild that came out of some of those early discussions. And please feel free to interrupt me and ask questions as we go along. So the motivation really was driven by all the challenges that we face in managing our network. So at Google, for example, we have more than 20 different roles of network devices. And for a typical service provider or a telco, I would expect to see many more. So I think we have a relatively simple network deployment, but still there's a lot of complexity and scale to it. We have a multi-vendor network, as you might know, right? So we have more than half a dozen vendors in our network, and each with several of those vendors, we have multiple platforms from them. We have tons and tons of configuration that we need to manage, millions of lines of configuration that we need to actively manage and maintain. And there's tons of churn in the network, right? So we're draining links, draining services, adding capacity, removing capacity, redirecting capacity. All of these things result in configuration changes, not to mention failures that happen that need to be reacted to. So we have on the order of roughly 30,000 configuration changes in our network per month. And then from the monitoring side, we're collecting huge amounts of data from our network. So more than 8 million object IDs from an SNMP perspective, roughly every 5 minutes. And then we have more than 20,000 CLI commands that we're issuing to basically scrape information from devices so we can manage and understand what's going on in the network. And that's also sort of at a 5-minute time scale. So we end up essentially with many, many different kinds of tools, multiple generations of those tools, all sort of adding to the complexity of managing and operating our network. So there's plenty of opportunity here to get significant savings from an operational expense perspective. And the immediate impact would be around reduced outages, simplifying and consolidating our management stack, better automation in terms of removing or reducing the number of manual interactions that we need to have with the network, and of course, better scaling. And so, as I said at the beginning, we've had this whole movement. We live in the era of open networking now. But what does network operations look like in this brave new world of open networking? Unfortunately, we're still stuck with lots and lots of proprietary integration. So from a management perspective, openness seems to have passed us by. So whether it's through CLIs, through scripting, through templating systems, or you pick your favorite automation system, whether it's Puppet modules, Chef cookbooks, Ansible minions, whatever you want, those have all helped us with automating our operations, but it hasn't gotten us away from all the proprietary integration that we need to do. The second, of course, is lack of real abstraction for managing the network. We're still managing the network by twiddling very kind of low-level knobs in the network, and someone who has to, and the skills required to understand those knobs are significant and specialized. And we also don't have any real common APIs to actually manage the network. we still live in a world where configuration lives on devices. So the authoritative configuration is basically scraped from devices and then reasoned about in some management system. Whereas what you really want in a declarative configuration system is you have a centralized management system, logically centralized, in which the authoritative configuration is stored, and devices actually are known to be in that configuration, or they're reconfigured. Sorry. Am I going to lose my display? All right, let me keep talking while we're doing this. And then finally, on the monitoring side, we still live in a world where we're primarily relying on SNMP for monitoring. So we'd love to be able to use standard MIBs for monitoring, but where you typically end up is with lots of reliance on enterprise MIBs and proprietary data that you have to collect from devices. So what would an open management plane look like? So we've talked about sort of where we are today. An open management plane, in our view, has three primary components to it. One is basically a common API. I said we lacked this before for configuration and for monitoring. So this API would work across vendor devices. So it doesn't matter what vendor device I'm using. I can use the same API both to configure the device and to read data from the device. Similarly, I want to have a new way of monitoring my network. SNMP, I don't know if folks are experienced with managing large-scale networks, high-density network devices. If you actually try to walk the MIB in one of these devices, as we get to thousands of ports, for example, just interface statistics might actually make the device fall over. So this is not going to scale as we go to next generations, as we get to higher and higher densities. So we need a new way to think about network monitoring. And so here, we view this as being realized through transport and RPC protocols that are open, that are built on a streaming model where devices actually stream the data to the management system, and that, of course, have security as a first-class element. And then finally, there's the notion of having an interoperable network-wide view. So this is about having a topology model that's common, that can be shared between network devices and the management system. So there's a common understanding of what the elements of the network are and what the connectivity looks like. And so where this takes us is, shouldn't surprise folks here at Open Daylight, is towards a more model-driven way of thinking about network management, where we have models that define configuration. So models for configuration describe configuration data structures and content. Models for telemetry or monitoring that describes the monitoring data in terms of its structure and its attributes. And then finally, models for topology that describe the structure of the network. So with OpenConfig, we've really taken the approach of moving our management systems towards a more model-driven system with a focus on configuration and telemetry. I'm not going to talk as much about topology models today. So I'll say a bit more about telemetry. As I mentioned, we have some requirements for telemetry going forward that really require us to completely rethink the way that we do network monitoring. So in fact, I'll tell you that our goal in, at least for our own organization, is to be completely SNMP free in a matter of 2 years. So we don't want to use SNMP in our network anywhere by 2017 if we can get to that. So in this model, network elements essentially push or stream data to collectors that you can see distributed in the network here. The data doesn't come across in some proprietary format. It's populated into a model that is common and it's vendor neutral, right? So I can get the same data from all my devices regardless of which vendor is actually sending the data. It has the notion of publish and subscribe, so I can filter data that I don't care about, and I can subscribe to specific data that I want, maybe at a frequency that I can specify. And as I mentioned before, we need a system that can scale with the next 10 years of density growth. If you look at the way switches are growing in density, routers and switches are growing in density, the mechanisms we have today simply won't scale. And then finally, we need a modern transport mechanism. And a transport mechanism that's open and that also has active development associated with it. Unlike SNMP, which I think has been relatively stagnant for a long time. So we have some ideas in this space. At Google, we just open sourced a transport protocol called gRPC, which is essentially an external version of our internal RPC protocols, both the IDLs as well as all the code and other mechanisms needed to realize both clients and servers. There's other options like thrift. For cases where you don't have the ability to actually encode data or set up RPC endpoints, for example, if you're streaming data directly off hardware from the forwarding engine in a router, you may have to settle for something simpler, like a simple protobuf that's just sent over UDP. So as we scale these devices, we're going to end up having to push more of the streaming and data collection from the management processors to the actual hardware. So we're going to have to adjust our transport accordingly. So guys, can we do something about the display? Okay. Go ahead. Yeah, it could. I mean, I think here we would like to replace even the statistics that we get via SFlow and have it all delivered via the same model. But yes, I mean, SFlow at least gives us some parts of these, or meets some parts of these requirements, but not all. As in installed by us? Yeah, so the point of this is that it may very well require a new agent to be installed by the vendor. But as an operator, I don't care how you stream me the data. If you need to install an agent and that's your architecture, that's fine. So what we're seeing, though, is that some vendors think that they can scale their system such that, through the regular management channel, through the management processor, they can send all this data. Other vendors are saying, no, it's likely that we're going to have to split this up so that some of the counters, for example, that are coming from interfaces will come directly from the hardware forwarding engine. And then you have other statistics that will come from the management processor. So I think different vendors will have to go about this different ways depending on their architecture. But from a consumer point of view, I want the data in a common model, and I want it streamed to me. So, and I don't care how you implement it on the device. Make sense? Yeah.
Do you have anything about strobing it over time so that not every device in the network is waking up every 5 minutes and blasting the collectors?
I'm not worried about blasting the collectors. We have enough server horsepower that I'm not worried about distributing collectors. So we haven't concerned ourselves that much with that problem. I think that we have sufficient capacity in the management network to be able to handle the data at the rates that we're expecting. But if it does become a problem, then sure, I think that is an option, is to basically stagger the data collection frequency. And that would be part of the API potentially, in which you specify the frequency and maybe period of getting the data back. OK, so this leads us to some of the motivation for OpenConfig. Basically, as I said, what we're finding is that management interfaces for devices are vendor-specific. Within a vendor, they're platform-specific, and sometimes they're even generation-specific. Right? So where that leaves you is essentially with protocols that have been proposed that still aren't solving the problem for us. Right? So we have netconf, we have restconf, we have SIM, we have SNMP. We have a bunch of standard protocols, but none of these are really addressing the problem of these proprietary integrations that we have to do. And other people have argued with me when I've presented this before that, hey, what about Puppet and Chef and Ansible? Don't these solve the problem for you? I mean, the simple answer is no. I mean, they don't actually address this problem. They give you automation. They give you a different way of interacting with the system, but it's still through proprietary integrations. I need a different Puppet module for Apache and a different one for Nginx and a different one for whatever other browser I'm running. I don't have an abstraction for a web browser that is the same across different flavors. And so what this has done is push a lot of the complexity and cost of management basically to the operators. So it's being pushed from the vendor devices. And I'm not trying to beat up on vendors here. It's just a statement of how we kind of are viewing the world, where we have to basically build, integrate, and test a whole bunch of software tools that are managing all these proprietary integrations and all these variations. And if you think about it, if I'm trying to manage BGP on device A and device B from these two different vendors, is it really necessary that the syntax and the semantics of the commands be completely different? I mean, it's a standard protocol. The RFCs are out there. They've been published. The behavior should be more or less the same. So we've kind of are coming to the conclusion that we're doing a lot of this work to integrate that's really not necessary. And then finally, just from a skills perspective, you end up needing to have specialized skills just to be able to manage your multi-vendor network. So at Google and at many other service providers, we don't want to be in a single vendor situation, right? We want to have multiple vendors in the network because it gives us lots of advantages just in terms of reliability, for example. And for doing that, it means that we are going to be living with a multi-vendor network. And I think every service provider or every network operator is in the same situation. And what you end up having to do is have people who understand this particular platform really well or that particular platform, and they're ultimately configuring and managing the same thing. So what is OpenConfig? Let me say a little bit about it at a high level. Basically, it's an informal industry collaboration of network operators. So we've got a bunch of network operators together who are working on defining these common APIs. So this is a case where it's users who are taking the job of defining the APIs and interfaces into their own hands. And our focus initially is on defining these vendor-neutral configuration and operational state models. So operational state you can think of as the monitoring side, based on real operations. So what we do is use our actual operational workflows and models and configurations to drive the development of the model. So we don't look at, for example, what standards have been published, what box A or box B supports. We look at our own configurations, what do we run in our network on a day-to-day basis, and make sure that the model reflects that first. So we don't try to be feature complete. We try to reflect the actual use cases that we have. Our primary output today is basically model code. So we're not a standards organization. We don't publish that many documents, although we do publish drafts to explain the models. But our primary output is intended to be model code. We publish it as open source via public GitHub repo. And I don't see Tom, but Tom Nato has helped us by giving us access to the public Yang model repo that he maintains as part of his netmod role in IETF. Although it's a group of operators working together, we have really close partnerships with vendors as well. So we work with major vendors, and I'll say more about this, to drive native implementations of these models. It doesn't do us any good if at the end of the day we define this model and then we have to do the translation in our own management system to write configuration and read data. What we want is for the devices to natively support these models so that we can use them to basically write configuration and read monitoring data across different vendor devices.
Can you talk about what operators besides Google are participating in this?
Yeah, just give me one more slide. So as we work with vendors, we have a couple of key requirements. One is that this is not something that's sort of a side project. It's something that's fully supported as part of the software stack on the device, and it's maintained as part of that platform software. And second, that it's available to all the customers. It's not just a special for one operator. It's not just a special for Google or for AT&T or for whomever. It's something that becomes a feature of the platform, that it supports this common data model. And in addition, we also have a bunch of engagements with standards bodies. We're active in IETF. We engage with ONF. We do work with other open source projects, Open Daylight being a key one, ONOS being another one. There's another open source project from NTT around a new BGP stack they're building. We've been working with them as well. And so you might wonder, why did we formulate this as an industry collaboration? Why isn't it okay? I mean, why didn't Google just do this on its own or AT&T just do this on its own? There's a bunch of reasons. I think they're fairly self-evident, right? One is just broaden the set of use cases beyond any single operator or customer. And it also simplifies life for vendors, right? If we can consolidate requirements and say, okay, here are the data models that a bunch of your biggest customers are asking you to support, it makes the calculations for a vendor a lot easier in terms of where they should invest and where they should put resources in terms of supporting models. We also get, obviously, better quality models through a wider review, subjected to more use cases, and just the critical mass of having more people working on developing models is another obvious benefit. And then finally, every network operator has a different philosophy, a different set of technologies that they use to manage their network. So different network management system approaches are reflected in the set of participants, and this sort of collaboration ensures that what we build is relevant across all of those use cases. And so the question was about participants. Who else besides Google? The set of participants we have so far in the few months that we've been working at this, include a whole bunch of different operators across a spectrum of use cases, network environments, different vendor deployments, different service and business models. So we have some traditional service providers or telcos. We have some cable operators involved, and we also have a bunch of web-scale network operators. So it runs the gamut of all of these use cases. We're always interested in additional operators joining, especially on the smaller operator side. This isn't an effort that's necessarily limited to just large operators. We have put an FAQ together for operators, so if you represent an operator and you think you'd be interested in working with us, have a look at that FAQ. It's on our website, openconfig.net. It just lists some of the guidelines that we ask people to follow when they join the group. So this is an open source industry collaboration. First question that comes up, well, what's the governance model look like? So the short answer is that there is no governance. There's no board, there's no steering committee, there's no bylaws, there's no chairman. We avoided any legal agreements, any certifications. Just imagine at these large service providers, if we got lawyers involved, we would be here a year later and probably still far, far away from having anything actually up and running. So we avoided all of that. And I have to give credit to our legal team inside Google because we saw that there's risk in this sort of model. But they encouraged us to go ahead and just try to rely on essentially people behaving well and being transparent and having a shared set of goals. So far, it's worked tremendously well. I mean, I think we're very pleased with the fact that, using a bit of a radical model for formulating a collaboration like this across even competing network operators has worked out so well so far. So what we do operationally is we just have weekly working meetings. And the participants here are essentially engineers and architects who are closely involved with network operations. So that's one of the requirements that we have for operators who join. There are folks and operators that are in architecture teams, for example, that are a little bit distant from operations, or folks who focus more on standards. We really want to have folks who are very closely and intimately involved with operations, right? So that we can vet our models against actual operations. So these are folks who are committing and actually reviewing model code. And then we use GitHub to raise issues and discuss the models. We have our mailing list that we use. And then we publish the model code, as I said, in a GitHub repo under an Apache license. So it's a very simple working model for this sort of collaboration. And we have some pretty big companies that have managed to work together and produce a bunch of stuff over the last year. So I like this term that was coined by the new IP in light reading, which is collaboration innovation. So I think this represents sort of a different model of how to formulate an industry collaboration. So the quote here is that the fact that these distinctly different and often competitive service providers are working together is an indication of the urgency they feel. And yes, I mean, there is an urgency to transform our network management, right? And this is one avenue by which we're pursuing that. And then there was another quote about how OpenConfig serves to provide a testing ground for working out kinks before turning the specs over to the official consortia. So we're not starting with standards. We're starting with model code. We're actually using the code in our own management systems, trying them out in production, finding where there are problems, finding where there are gaps as far as what they can represent, iterating, and then eventually, if we decide to pursue it and if the standards bodies are interested, they may turn into standards. We hope that they will. So how do we go about this development of our models? There's a lot of questions that come up about how do we work with vendors, how do we work with the broader community. We're definitely interested in doing that, and we do a lot of that. So the way this works is that we have a set of operator requirements that we identify through our meetings and discussions. We basically have built a roadmap of the models that we need to enable us to deploy, for example, our management system on a particular device role. So we start building these models after reviewing actual configurations, as I said. So the actual configuration helps us scope what needs to be reflected in the model. And then we develop and iterate on a draft of the model. And I didn't mention, but hopefully people know that we've used Yang as the modeling language, since that's where a lot of the industry traction has been so far. So we develop our model draft. We continue to review our own configurations. We also spend a lot of time looking at vendor implementation. So we don't ignore what vendors are capable of doing. We actually only put things in models that are supported by major implementations, right? So we don't build the models in a vacuum without considering actually how they would map to a given implementation. And the mapping is not always perfect, but we try to make sure that there is a mapping from the model to the major implementations that we care about. And then we start the review process with the broader community. So we start with implementers, right? So we go to specific vendors and implementers and share the models, get feedback, revise the models based on their feedback. For example, we've made lots of revisions to the BGP model that we've worked on for the last several months based on vendors saying, hey, if you change this container or if you move this to this part of the hierarchy in the model, it will make it a lot easier for us to do the mapping. And so we said, OK, we're not losing any feature by doing that. It still makes sense operationally to do that. So we go ahead and make that change. And then ultimately, we can publish the model code as a more or less stable version of the model. And of course, stable is relative here, right? So until you deploy it in production and use it, I think we don't claim that it's done, right? We have a lot of work to do to actually use it, work out the kinks before rushing to try to standardize it. OK, I'm doing OK. So how far have we gotten over the last year? So I think we've made a bunch of progress in a few different areas. No. Are we OK here? So we have a bunch of progress on data models, right, both for configuration and for operational state. We've published a model for BGP and routing policy. They're actually two different models, but they work closely together. We have multiple vendor implementations of the BGP and routing policy models in progress, and I'll say more about that. The BGP model has also been adopted by the IETF for standards track, which is great news because it makes life, again, easier for vendors. We've also proposed the routing policy model for standards track, and hopefully it's on track to become to go on to standards track by being adopted in the routing working group. Jeff can comment. OK, great. So Jeff Tansur is the co-chair of the routing working group in IETF, and that's where the routing policy model has been published. We have a model for local routing. So things like static routes, aggregate routes, locally generated routes matter to people, and we use them in our networks, and we need a model for them. So we have a model for that we've published, also in the routing working group. We spent a lot of time on an MPLS and traffic engineering model. It's another fundamental building block for operating our networks, right? So we have spent a good deal of time, in particular, on the RSVP and traffic engineering portions of the MPLS model, as well as segment routing as a first focus areas. But it includes a general framework for consolidating all of MPLS, including LDP and other protocols, in one framework. So I think the difference between the approach we've taken with our MPLS model, for example, is that operationally, we don't want to think in terms of protocol-centric. We want to actually look at our LSPs. We have LSPs that are signaled using RSVP. We have LSPs that might be signaled using SR. We have statically configured LSPs. But at the end of the day, we want to think about these as the set of label switch paths that we're managing. Not that, OK, we're managing RSVP, the protocol, we're managing LDP, or we're managing segment routing. So the idea of our model is essentially to create a single framework that consolidates all of MPLS in a way that we think is operationally sensible. So it's a bit different than the approach that's been taken by the industry in developing MPLS models, for example. We also have published a device model. One interesting thing about Yang models, if you follow that area, is that they're kind of built in isolation. And if you actually need to run a network, you need a bunch of these models that work together. So a device isn't just BGP or just MPLS or just interfaces. It's all of these things plus a bunch of other things that you need. And so you need a framework for a device that lets you put these models together in some sensible and coherent way. I'll say a little bit more about that. We've also spent a lot of time not just on the models themselves, but also on proposing some design patterns for how you build models. So in particular, very little attention has been paid to how you model operational state in these models. It's really been focused on configuration. And we think, as network operators, operational state and monitoring are key parts of any data model that we are developing. And so we've come up with some design patterns and proposed them and published them and have been debating them in the community, as well as some mechanisms of how you compose models. And then we also, it's interesting, the explosion of Yang models. We have Yang models coming out of IETF. We have Yang models now being published by OpenConfig. We have a whole bunch of Yang models that have come from Open Daylight. IEEE is now starting to publish Yang models, MEF. So many organizations and so many sources of models. As a user, if you actually want to use the model, you really have to kind of figure out how to wrap your head around all of these different models, where they come from, do they work together, are they implemented on any real platform? So the other proposal that we had that is slowly getting some traction is actually we're not sure where this should live yet, essentially is to have a catalog. Think of a service catalog from an IT services point of view, where you can actually have registration of models and some metadata about them that talks about their licensing, what platforms they're implemented on, what dependencies they have, and so on. So it makes it a little bit easier at least to go to one place to find out the set of models. So as a user, I don't have to then go hunt around for figuring out all the different dependencies that a particular model I want to use has. So continuing on with progress, we have a bunch of models that we're currently working on as well. So we've got an updated interfaces model and a system model. I'm mentioning these because there is a standard model that's been published by the IETF for both of these. We've kind of taken a fresh perspective on them and looked at how they can be improved and extended. We have a model for representing routing tables in a common format. This is a key part of our monitoring infrastructure, for example, and it's also used by network operators to debug their network, right, to really understand the contents of the routing table before policy, after policy, inbound routes, outbound routes, all of that. We also have reviewed or developed and now are reviewing models for optical transport devices. So towards deploying transport SDN in our networks, we have now a terminal device model, and we're going to have an amplifier as well as a ROADM model that we'll be publishing pretty soon. We also spent a bunch of time on tools and APIs around modeling. So Rob Shakir at BT has published a tool called PyangBind, which is essentially something that he's developed kind of on his own, but under the OpenConfig umbrella, which essentially generates code artifacts from Yang models. So if you are writing an NMS in Python, for example, you can use his tool to generate Python classes directly from Yang models and also do validation of the data instances that you create. We're also working on some protocol-independent specifications of what configuration RPC should look like. One problem that we've noticed with Yang is that it's very netconf-centric, right? So there's always this assumption that you're going to use netconf as the management protocol. We're not interested in using netconf, for example. Other operators may or may not be interested in using netconf. So at the same time, we think Yang is very useful for data modeling. So what we want to do is publish some specifications of what RPCs ought to look like, regardless of what the underlying protocol is that you're using. And this is something that we'll work with our vendors to implement. And then native implementation. So the first and most mature model that we published, or the first couple of models, is around BGP and routing policy. And I'm happy to say that Cisco is supporting the models in iOS XR. So starting with release 5.3.2, you'll be able to configure BGP using OpenConfig data models on a Cisco device, both the virtual version and the real iOS XR hardware. And then Juniper also is committed and is publicly committed to supporting OpenConfig BGP and policy in Junos. And then we are talking to other vendors who have also committed, but they're not quite ready to publicly state their commitment. So they have implementations underway, and hopefully we'll be able to say more about them soon. So I talked a little bit about model composition. I mean, this gives you some idea of what I'm talking about. Essentially, one problem with Yang model development is that it happens in isolation, right? So to actually configure a whole device or a whole service, you need a multitude of models that work together. So we've tried to propose, a structure for how models can fit together to, for example, realize an entire device. And one of the things that needs to be added, for example, to Yang is some mechanisms to help you build compositions like this, right? Today, it's very difficult to do this given what Yang provides you with in the current version of the language. I said a little bit about operational state. We essentially look at operational state as three different types, right? You have typical monitoring data where you have operational state that's derived or that's negotiated via protocols that are running. So an example would be like your negotiated BGP hold time. That's one kind of operational state. The second kind is what you typically think of in monitoring, which are things like interface counters, right? State data that comes from counters or statistics, say from interfaces. Or prefixes that are exchanged between BGP peers. And then we also have a third category of operational state that we've argued is crucial, actually, is that representing the actual applied configuration. So if you think about it, you can view configuration as just another form of state of the system, right? So you have the state that's intended to be written to the system, and then you have the actual applied state. And they may not necessarily be the same. If my system is not fully transactional or fully synchronous, there's obviously going to be a delay between when my intended configuration becomes the actual or the applied configuration. And if you're running systems as we do and as many people do that are asynchronous or that have eventual consistency behavior, you need to be able to monitor the state of the network, including its current configuration. So it helps you, for example, see when there's mismatches and to be able to reason about them. It helps you see how long it takes for an intended configuration to actually become an applied configuration. So we strongly believe from an operational perspective in OpenConfig that the actual configuration should be considered part of the state as well. And our design pattern for modeling operational state reflects that. We see clear benefits from using Yang to model both configuration and operational state data. Having them in the same data model gives you basically a bunch of benefits, including having this common structure of the data, not just for what you configure, but also what you read from the device. And then, as I said, it allows for easy correlation between associated configuration and state data when you have both of them in the same model. But so far to date, Yang has been primarily focused on configuration. I think even if you read some of the IETF documents, you'll see that a lot of the focus is on configuration, although it does support operational state to some extent. And it's very netconf-centric. So if you're not using netconf, it's not clear that you can do everything that we want to do in terms of modeling operational state. And we can talk offline more about that. And there's no common convention of how operational state should be modeled in Yang. And one of the design patterns that we proposed is essentially a common convention that modelers can use to represent state data as well as configuration data. So just a few observations. My footnote on this slide is that these are kind of my own views. They're not necessarily consensus views inside OpenConfig, but I will go out on a limb and say that there's a lot of general agreement with some of these. The first is that Yang and netconf should be decoupled, right? They're both independently useful things, and they have been a little bit tied together, which has made some things complicated. Yang as a language also, it takes a long time to iterate on it today. I think that Yang 1.1 will hopefully be published very soon, but it's taken a very long time to go from Yang 1.0 to 1.1. And given the lack of sort of wide deployments of Yang model-based network management systems, our feeling is that we should try to evolve the language more rapidly as we get experience with it. And then stabilize the language, as real usage in production increases, right? As we see real deployments out there. The other issue that I think we've seen with Yang is that the folks who are currently driving the language represent, maybe a limited set of perspectives. I think what we need is a lot more review and more input from a much broader set of users that come with different perspectives. So from our point of view, we're a consumer of these models, right? We're writing the models, but we're also on the user side. So there's also the vendor perspective. They have to implement support for the model on essentially on a server, right? On the network system. There's also the perspective of folks who are writing Yang tools, compilers and parsers for Yang. So these perspectives haven't been equally represented. I think that's one of the problems with Yang's development so far, and I think this is something that needs to change. One real pain point that we've had, especially as you start to combine models together, is that if you look at how Yang models are versioned, they essentially have a date string. It's a revision date. It's treated almost like a dated document. It's like a letter that has a date on it, right? It's not treated like a software artifact that has a major version and it's got a minor version and it's got all the things that you expect a piece of software to have that gives you some indication about backward compatibility or when you can expect big changes to the APIs. I think it could benefit from a real bona fide versioning system that wouldn't be that complicated. And then finally, there are some standard models out there that I think we should be really open to revisiting and revising if necessary. The problem with the standard models that have been published is that they're not used widely in production, I think by everyone's admission, right? So we're in a situation where we have some models that have been, published as RFCs, and we're naturally reluctant to go back and change them because they're RFCs. But the problem is that they're not really used that widely yet. So our view is that until models are actually used and in production and deployed and people have experience with them, we shouldn't rush to standardize any more models. Let's sort of stabilize them, get some real use out of them, iterate a little bit, and then we can think about standardizing them. And that's the approach that we're taking in OpenConfig, at least. So we're at the Open Daylight Summit. What does this have to do with Open Daylight? So I wanted to first sort of introduce to some of you have heard this before, OpenConfig as another sort of industry collaboration around network management. But I think there's some real synergies with Open Daylight that I wanted to highlight, and hopefully people will take away and build on. So first is, Open Daylight as a network management system. Open Daylight was conceived, and I was involved in the conception of Open Daylight in the early days, as a controller, right? It's an open source controller, it's a control stack. If we start to think about Open Daylight as also potentially a really capable network management system as a first-class use case for Open Daylight, I think that could really help us get to a point where we have an open, extensible system for network management in which we can try a lot of these ideas. So I would really encourage there to be more focus on more management and operations projects. The other sort of place where there's synergy is just support for the OpenConfig models. The OpenConfig models are, open source, vendor neutral. They're a good fit with an OSS project like Open Daylight. So one thing that we'd like to see and like to help with is, helping Open Daylight consume the models and provide them as interfaces to some of the Open Daylight capabilities. And then finally, there's a really high concentration of Yang expertise in the Open Daylight community. And I think there's a lot of work that needs to be done. If we want to see Yang actually succeed in the industry, we need much better tools. We need to enable more experimentation with the language. I think Open Daylight can serve as a real catalyst for some of that. And I'll say a little bit more about each of these. Some of these things are already happening, by the way, in Open Daylight, so I'll highlight some of that. And by the way, although this is, I think we have a great opportunity with Open Daylight, these comments that I'm making are not specific to Open Daylight. I think there are other open source projects that the same opportunities exist for, whether it's OpenFV or whether it's ONOS and others. So Open Daylight as an NMS, the good news is that there's already a bunch of management and operations features in Open Daylight. So for example, around monitoring and path management, we have things like SNMP and BGPLS and PCEP. And yes, I said we're not interested that much in SNMP, but the fact is that it's there as a protocol if you want to use it for monitoring. We have some network configuration protocol support in terms of netconf and restconf, as well as OVSDB. There's support for data management and modeling. Of course, we have the Yang tools project in Open Daylight. There's the TSDR project, which is for managing time series data. And I think there's some additional capabilities that we should think about. Maybe a collector project, right, for being able to collect the streaming telemetry that I described with publish subscribe capability. There's actually some very interesting drafts that have been published in IETF on pub/sub monitoring. It's in the context of I2RS, if folks are familiar with I2RS, but some of the ideas are sort of widely applicable there. Support for additional data transports and encodings in terms of monitoring data. So, for example, gRPC or Thrift encodings, including JSON or protobuf, et cetera. And then also additional support for actually validating configurations. So I think all of these are potential opportunities for Open Daylight to extend its scope into management a bit more and actually help the operator community by giving us a way or a platform on which to try some of this stuff. As far as supporting OpenConfig models in Open Daylight, there's a few immediate candidates, and I saw Jan earlier today, but he was working with one of his colleagues at Cisco in terms of being able to support the OpenConfig BGP model. So I think pretty soon you'll be able to configure BGP in Open Daylight using the OpenConfig model, and I think there's other opportunities there as well. So MPLS TE, our model has support for server-based path computation, like what you do with PCEP, or segment routing. These are two other candidates that we might be able to use the OpenConfig models to configure those capabilities in ODL. And then finally, developing the Yang ecosystem, right? So I think the OpenConfig models have been a great source of input data, essentially, for the Yang toolchain in Open Daylight. And I've been working with some of the folks in the Yang tools project to work out kinks both in their tooling as well as in our models. So that's been a helpful exercise. The work that Open Daylight is doing to make it easier to visualize and experiment with models has been really great. I think if you look at the Yang UI project, there's a talk about it. I think later today or probably tomorrow. It's a really nice way to basically interact with Yang models and understand their structure. It's very useful for people who are authoring models. There's also a bunch of projects now that are trying to take Yang models and generate code artifacts from them. So Open Daylight is doing this for Java, obviously. There are other projects out there that are developing code artifacts in Java out of Yang models. I mentioned the project that Rob Shakir started on for Python. There are other projects that are doing the same for Go. So without some consistency across how these code artifacts are generated, it'll be very hard to interoperate. So I think this is another opportunity where we have to interact with the Open Daylight community to make sure that there's consistency in this code that's being generated from Yang models. And I'll emphasize this next point on, I think we need a lot more work on improvements to the Yang modeling language. So basically, having a user or an implementer perspective that complements, what's happening in the IETF standards area to drive the language forward and to make it more useful. There's a bunch of major shortcomings that I think the language has around things like lists and versioning, as I mentioned, how it deals with cases or choices, lack of support for model composition, that I think that, along with Open Daylight and other interested parties, we could start to address. If you're interested also in Open Daylight's view on this, Colin gave a talk at ONS recently. I think it was called Yang Modeling, the Good, the Bad, and the Ugly. So he also highlights some of the same issues with the language. So wrapping up, we believe from an operator's point of view that network management needs a much more model-driven approach, really, to make it part of the era of open networking and programmable networking and SDN. OpenConfig, as I've described it, is what we think is a new kind of industry collaboration. It's informal, but it's been pretty effective. I think you've seen the progress we've made over the last year. I think we're very pleased with it, but there's a long way to go, obviously. In this model, we have network operators that are directly contributing the open data models, the tools, and the design patterns for creating the models. I think as we see more native implementations become available, so I already mentioned a couple that are in progress, it really has the potential to really transform the way we're doing network monitoring and configuration. I mean, having a common API and interface would basically remove the need for so many of these proprietary integrations that we're stuck doing today. And then finally, I think there is a major role for Open Daylight and other open source projects really to help realize the vision. So with that, I'll stop there. And if there's any questions, I'm happy to answer. Yeah?
So the vendors who were mostly worried about were the hardware vendors. What about OpenConfig? Does that also need to implement the model that you're talking about?
So it's true that we started by focusing on hardware devices, but I think the same applies for software devices also. I mean, probably the set of features that you worry about on an Open vSwitch, I don't have a BGP implementation I'm trying to configure like I am on a router, right? But I do have interfaces and VLANs and tunnels and lags and things like that that may be applicable. So certainly the models that we're developing around interfaces, it would be great if we could see more software-based devices adopt them. Yeah.
So the ONF has a optical transmission and calibrated to input on the Yang model for the transport. Have you worked with them about this?
Yeah, so we actually presented in that working group recently just to get some feedback from them and to let them know about what we're doing. I wouldn't say we've fully developed that collaboration, but yeah, I mean, I think we are in touch with them. They do know about the models. We had some follow-ups. I think the main feedback was basically around things like terminology and so on to try to align it with the kind of terminology that they were using. But I think that they saw value in the models that we're building.
So that's my comment on that.
Okay. Yeah.
At a high level, what is involved for a vendor to actually implement like hardware devices to do this? I mean, is that, are they kind of expected to contribute back to your project code modules or whatever?
No, they're not expected to contribute back in terms of code, and it's different for every vendor, right? So, but in general, the pattern that we've seen with the vendors who we're talking to is all the vendors are building Yang models that reflect their own systems configuration and data models, right? So these are what we would call their proprietary data models. So they're working on those. They now have the question of how to support externally defined models. So if a customer like us or like OpenConfig wants to use a different data model than their native model, it requires some translation, obviously, and that translation can be done a bunch of different ways. So you submit data according to one model. It has to be transformed and manipulated so that it fits their native data model and then gets validated and applied, essentially. Right? So there's that development effort is what's involved essentially in the initial implementation. So the sort of, although they don't contribute code directly back, we certainly incorporate the feedback that they give us on the models themselves, right? The model has this feature that's really not supported in our platform. That may end up being a deviation in the model. If it's something that we believe should be in the model, it's just that that platform doesn't support it. Or it's something where we might reconsider removing it from the model because we find that it's just not widely supported. So that's the kind of feedback that we're getting, we want to get from vendors as we go forward.
Well, that addresses the modeling aspect, but what about the protocol? You said you wanted getting rid of SNMP.
So you will see support on some of the platforms that I mentioned for this model of streaming telemetry in the pretty near future, probably by year end. So it essentially, we're asking vendors to look at supporting different transports. So essentially, for example, in our case, we're pushing for gRPC. gRPC is built on HTTP2. It's got a lot of nice features like bidirectional streaming and framing and security that we can leverage, and it gives us a way to set up a stream of data from the device. So, and we have a bunch of code artifacts that have been published. So a vendor, if they can set up a gRPC endpoint on their end, set up a connection with our collector, it's just a matter of them then taking the data that they would normally make available via SNMP or some other mechanism, putting it in the data model that we've defined, right? So again, it has to be in the common data model, and then streaming it to us. And there's different kinds of data, right? There's some data that you want over a continuous time series. There's some data you only want edge triggered. When an event happens, that's when you want to be notified. You don't need to know about it every 5 minutes or whatever. And so we're working with vendors to actually support all of these different modes of data over these new transport mechanisms. And other operators in OpenConfig will ask for support for potentially other transports as well, aside from gRPC. Yeah.
So really, though, what you're providing to the industry is a set of minimalistic requirements in OpenConfig that you want from the vendor industry based on the model that you use the operation useful. It doesn't include you as a vendor adding more features and capabilities.
Of course.
That you're not using, right? So really, it's just compliance to that model. So even if you had your own model, you feel that you tweak it to match the OpenConfig.
That's correct. I think the only thing I would modify in what you said is that they're not lowest common denominator models. We don't consider them minimalistic in the sense that they're everything that we need to be operational, right? And it's not just that we need, it's what all the operators who are involved need. So it represents a fairly full feature set. It doesn't have all the esoteric features that a particular platform may include.
That would be a distinguishing feature on a vendor to have those capabilities because,
Yes.
like in SNMP, you don't get everything to monitor just in SNMP. There's lots of
Exactly. So vendors are free to augment the models with additional things. If I'm a customer of some vendor that uses some specific knob that only that vendor supports, I will need that augmentation to be able to operate my network anyway. Any other questions? Yeah. What would you say is the standard BGP model? I'm sorry, are you talking?
I can give an example of that. Right? So, for example, the IETF says that the BGP decision-making process should start with a local preference parameter, right? But if you go to Cisco, you'll get a Cisco proprietary parameter called admin weight, which takes precedence over the local preference parameter. So does admin weight come into your model?
not if it's specific to a single vendor. So for BGP, things that aren't in the RFC, in whether it's 4271 or all the other RFCs that have been published that add features to BGP, unless it's used widely and implemented widely, we don't include it in the model. So and also we try to knobs that, for example, reflect something that's standard but uses a vendor-specific terminology, will actually in the model use the standard terminology. We'll try not to follow a particular vendor's terminology or style. So we've actually tried hard to make it relatively vendor neutral wherever we can. And that's what we mean by vendor neutral. It has to be something that's implemented by a bunch of major vendors. And I can't say that it's implemented by every vendor because it's the vendors that the operators who are involved in the group actually care about, right? So we ask them to go look at their implementations and see, is this supported? Do you use it? If you don't use it, even if it's supported widely, we don't include it. Because if no one uses it, why do we care about it being in the model? That's kind of the approach we've taken. I'm speaking a bit roughly here, but that's at a high level the kind of considerations that we take when developing the models. I mean, the standard MIB for interfaces, for example, has some stuff in there, but there's a bunch of other things that are widely supported that we use in debugging the network that aren't in the standard MIB, right? They come in enterprise MIBs. So what I think you'll find is that the model has a combination of what's in the standard MIB, plus a bunch of things that are in various kinds of enterprise MIBs, and we've normalized the namespace for them and normalized their location in the data model. So if you're asking how different they would be, I don't think you'll find any surprises in the model. They're things that every operator uses and needs. What we've done is try to normalize the naming, their location, and even describe the semantics in enough detail so the vendors know exactly what we expect when we get that piece of data. Anyone else? Okay, thanks again, everyone. In the era of open networking now. But what does network operations look like in this brave new world of open networking? Unfortunately, we're still stuck with lots and lots of proprietary integration. So from a management perspective, openness seems to have passed us by. So whether it's through CLIs, through scripting, through templating systems, or you pick your favorite automation system, whether it's Puppet modules, Chef cookbooks, Ansible minions, whatever you want, those have all helped us with automating our operations, but it hasn't gotten us away from all the proprietary integration that we need to do. The second, of course, is lack of real abstraction for managing the network. We're still managing the network by twiddling very kind of low-level knobs in the network, and someone who has to, and the skills required to understand those knobs are significant and specialized. And we also don't have any real common APIs to actually manage the network. We still live in a world where configuration lives on devices. So the authoritative configuration is basically scraped from devices and then reasoned about in some management system. Whereas what you really want in a declarative configuration system is you have a centralized management system, logically centralized, in which the authoritative configuration is stored, and devices actually are known to be in that configuration or they're reconfigured. Sorry. Am I going to lose my display? All right, let me keep talking while we're doing this. And then finally, on the monitoring side, we still live in a world where we're primarily relying on SNMP for monitoring. So we'd love to be able to use standard MIBs for monitoring, but where you typically end up is with lots of reliance on enterprise MIBs and proprietary data that you have to collect from devices. So what would an open management plane look like? So we've talked about sort of where we are today. an open management plane, in our view, has three primary components to it. One is basically a common API. I said we lacked this before for configuration and for monitoring. So this API would work across vendor devices. So it doesn't matter what vendor device I'm using. I can use the same API both to configure the device and to read data from the device. Similarly, I want to have a new way of monitoring my network. SNMP, I don't know if folks are experienced with managing large-scale networks, high-density network devices. If you actually try to walk the MIB in one of these devices, Hi everyone, thanks for coming to the session. My name is Anees Shaikh. I work at Google in the network operations team. I'm in the network architecture group within the operations side. I was actually at an Open Daylight mini summit about a year ago. It was August of last year, talking about the management plane. And really the theme of that discussion was around how SDN has sort of passed by the management plane. And we focus so much on control and data. We have some fantastic technologies in terms of open control stacks like Open Daylight, open data planes like OVS and other virtual switches, and a bunch of other open networking technologies. But as far as the management plane is concerned, we still have a bunch of gaps that I will talk about today. And so the motivation of that talk last year was basically saying, hey, we have been focused a lot on SDN from a control and data plane perspective, but we also need to put a lot more emphasis on management plane, because for network operators like Google and many others, operations are really where we see a lot of the pain points in deploying new technologies and operating them. And I ended the talk last year with some discussion of some ideas we had at that point about how we could do this work in terms of generating an open and equivalent in the management plane in a collaborative fashion. So just as Open Daylight has leveraged collaboration and community to a large extent to build a stack and a whole set of features and is slowly improving in its maturity, we didn't quite follow exactly the same model, but we also are trying to leverage collaboration. And so this is sort of an update of how far we've come in the first year. So that was August last year. We're just about in August of this year. So this is basically an update on where we are. So OpenConfig is sort of the brainchild that came out of some of those early discussions. And please feel free to interrupt me and ask questions as we go along. So the motivation really was driven by all the challenges that we face in managing our network. So at Google, for example, we have more than 20 different roles of network devices. And for a typical service provider or a telco, I would expect to see many more. So I think we have a relatively simple network deployment, but still there's a lot of complexity and scale to it. We have a multi-vendor network, as you might know, right? So we have more than half a dozen vendors in our network, and each with several of those vendors, we have multiple platforms from them. We have tons and tons of configuration that we need to manage, millions of lines of configuration that we need to actively manage and maintain. And there's tons of churn in the network, right? So we're draining links, draining services, adding capacity, removing capacity, redirecting capacity. All of these things result in configuration changes, not to mention failures that happen that need to be reacted to. So we have on the order of roughly 30,000 configuration changes in our network per month. And then from the monitoring side, we're collecting huge amounts of data from our network. So more than 8 million object IDs from an SNMP perspective, roughly every 5 minutes. And then we have more than 20,000 CLI commands that we're issuing to basically scrape information from devices so we can manage and understand what's going on in the network. And that's also sort of at a 5-minute time scale. So we end up essentially with many, many different kinds of tools, multiple generations of those tools, all sort of adding to the complexity of managing and operating our network. So there's plenty of opportunity here to get significant savings from an operational expense perspective. And the immediate impact would be around reduced outages, simplifying and consolidating our management stack, better automation in terms of removing or reducing the number of manual interactions that we need to have with the network, and of course, better scaling. And so, as I said at the beginning, we've had this whole movement. We live in